So if we want to graph this, we need to find all the critical points, and the first thing we want to do probably is find the hole. So if you look at the function, a hole is going to happen when you have the same factor on both the top and the bottom. So for us, that's going to be this x minus 3 and over the x minus 3. So what that means is there's going to be a hole with an x coordinate of 3. And then for the y coordinate, you can just take the limit as the function goes to 3, and what you'll end up getting is a function that looks like that with the x minus 3's crossed out. You can sub all that in, and what you're going to come out with eventually, once you do some math, is negative 35 over 24. So that's your hole. So now let's look at some of the x-intercepts. So we have x minus 2 and x plus 4. And what that's going to lead to is when you plug in x equals 2, you're going to have 0 on top, and that'll give you an x-intercept because the whole function will be 0. And also when you plug in negative 4, you'll have an x-intercept. So those are our x-intercepts. For the vertical asymptotes, you want to look at factors in the bottom of the fraction. So in our case, that's going to be x minus 1 and x plus 1. And so going by that same logic that we did for the for the x-intercepts, we can find that there would be vertical asymptotes when x is 1, because then you get something over 0, and that will be a vertical asymptote. That's kind of the definition of that. And the same right, if you plug in negative 1, you'll get it because this x plus 1 on the far right will go to 0. And if you want to find the horizontal asymptote, you first have to compare the power of the top and bottom. And so you can see with the top we have 1, 2, 3, and at the bottom we have 1, 2, 3. And if they're equal like that, then you go into the coefficient, which is kind of a tiebreaker. And what that leaves you with is y equals negative 5/3 will be your horizontal asymptote. Let's see if I can. There. Now you can see those things a little more clearly. And then for the y-intercept, all you have to do is plug in 0 wherever there's x, because that's the definition of the y-intercept is what y is when x is 0. And if you do the math on that, and you'll get just a good bit of multiplication and division, and you'll end up with negative 40 over 3, which is pretty close to negative 13. So then if we go in and try and graph that, you'll see I've labeled the asymptotes in red. You got the vertical at negative 1, 1, the horizontal at negative 5/3, and I've got other critical points in green. So you got the x-intercept at negative 4, another one at positive 2, another, and you got your hole, which is at 3, a little below, and your y-intercept all the way down here. So if we want to then connect the dots, then your function is going to look kind of like that, crossing through that x-intercept reasonably well. Down here, because the multiplicity on the or the horizontal asymptote is 0, you're going to cross all the way to the other side of the graph, and going to look kind of like that, and it's going to cross through there, and since there's no x-intercepts, it's just going to stay really low like that. And then over where numbers get bigger again, you're going to start high because it's going to cross all the way over and flip. You're going to go through that hole and then keep approaching that asymptote.